Let's look at actually putting everything together for sketching polynomials. And I want to look at if we have q of x is equal to 9x to the 5th plus an 18x to the 4th minus 4x to the 3rd minus an 8x squared. So putting everything together, let's start out with what is our leading coefficient? Well, our leading coefficient in this case is going to be that positive 9. Then we need to find our degree. And so the degree of this polynomial, if I could spell correctly, is, since it's in standard form, is going to be our largest exponent, which is 5. So what does that tell me about the end behavior of this particular function? So since my degree is odd, that means we're going to go in opposite directions. My leading coefficient is positive, so I'm going to be going up on the right side. And I'm going in opposite directions, so I'm going to be going down on the left side. Okay, so we have our end behaviors. The next thing that we need to do is we need to find those zeros. So I need to get this in factored format. And it looks kind of yucky right now. Well, let's start by taking out our greatest common factor. There's not a number, but I can take an x squared out. So I'm going to take an x squared out, and that will leave me with a 9x to the 3rd plus 18x squared minus 4x minus 8. Still doesn't look very pretty, but remember, I can factor by grouping. Group the first two, group the second two. And out of this first set, I can take a 9x squared out. And out of this last set, I can take a negative 4 out. So let's see what that will give me. That will give me that q of x is equal to, don't forget that x squared at the front. I'm taking that 9x squared out. So if I take a 9x squared out, that will leave me with an x plus, take a 9x squared out here, that leaves me with a 2. Take a negative 4 out, that will leave me with just an x plus 2. And so now notice that these are the same. And so I'm going to factor those out of my two terms. So I have q of x is equal to an x squared times x plus 2 times a 9x squared minus 4. Now out of this, I can actually still factor this. This is a difference of squares. And with that difference of squares, remember, I know this because I can take the square root of 9, square root of x squared, and the square root of 4. I'm going to get a 3x minus 2 and a 3x plus 2. And then I'm going to bring down that x plus 2 and that x squared. Now I have this in completely factored format, which I want to make sure that I get. And I'm going to set each of these equal to 0. So I'll get x is equal to 0, x plus 2 is equal to 0, 3x minus 2 is equal to 0, and 3x plus 2 is equal to 0. So in this case, x is equal to a negative 2. I'll add 2 to both sides, so 3x is equal to 2. X is equal to a positive 2/3. I'll subtract a 2, so 3x is equal to negative 2. So x is equal to a negative 2/3. So I have my 4 zeros, but I also need to look for that multiplicity. So I have a multiplicity of 2 for the x squared. I'm sorry, for the 0. I have a multiplicity of 1 for the negative 2. I have a multiplicity of 1 and a multiplicity of 1. So that tells me that I'm going to touch at the 0. I will cross at the negative 2. I will cross at the 2/3, and I will cross at the negative 2/3. So we need to know our zeros, what happens at each of those zeros, and our end behaviors. So let's go over to a graph. And so our zeros for this one were at 0, a negative 2, a positive 2/3, which is approximately here, and a negative 2/3, which will be approximately here. Our end behaviors were that we started down and we ended up. And at x equals 0, we were going to touch. At x equals negative 2, we cross. At x equals a positive 2/3, we cross. And at x equals a negative 2/3, we cross. Okay, so we come here, we go to negative 2, we cross. We go to a negative 2/3, we cross. We go to 0, we touch. We go to a positive 2/3, we cross, and we end. Okay? And so I'm going to erase this one, which matches up. So we have graphed, this is Q of x. Now I'm going to graph one more, and this one's going to already be in that factored format. This is going to be d of x is equal to a negative 6 x plus 4 times an x minus 5 squared times a negative x plus 7. So we're going to look for the leading coefficient, the degree, our end behaviors. Okay. So our leading coefficient, remember, whenever it's in factored format, we have to take into account all of our leading coefficients. So we're going to take, for our leading coefficient, we're going to have to take negative 6 times a positive 1 times a positive 1 squared times a negative 1. So negative 6 times positive 1 times positive 1 times a negative 1 gives me a positive 6. My degree means to add up all the exponents for those terms with a variable. So I have a 1, 2, 3, 4. I do not add this one because this one does not have a variable. So my degree is 4. I have a positive, so that means I'm going up on the right side. Since my degree is even, that means I'm also going up on the left side. For my zeros, I'm going to put each one of my factors with a variable equal to 0. And I will solve. And so I get that x is equal to a negative 4, x is equal to a positive 5, and 7 is equal to an x. Then I look at the multiplicity. So this one has a multiplicity of a 1. The 5 has a multiplicity of 2. And the 7 has a multiplicity of a 1. So I will cross at negative 4. I will touch at 5. And I will cross at 7. So on this one, since we had a leading coefficient of a positive 6, and we had a degree of 4, we're going to be going up and up. We had zeros at negative 4, positive 5, and positive 7. So I need to move this over some. So at negative 4, I'm going to cross. And I'm going to come way down because if I could get my y-intercept, it would be at negative 4,200. At 5, I'm going to, whoa, I can't do that. Okay, so at 5, I'm going to touch. At 7, I'm going to cross, and I will end. So that's d of x. Notice I came back and said I couldn't do that because I can't cross over this 5 until I actually get to 5. So practice some sketching of graphs, and let me know if you have questions.